Consider the system of linear equations. A1x plus b1y equal to c1. A2x plus b2y equal to c2. If a1 b2 minus a2 b1 is not equal to 0, the above equations will have a unique solution. The solution is b2 c1 minus b1 c2 upon a1 b2 minus a2 b1, a1 c2 minus a2 c1 upon a1 b2 minus a2 b1. The expression a1 b2 minus a2 b1 plays a very important part in the solution of simultaneous equations and is denoted by, within bars, a1 b1, a2 b2. Its value is a1 b2 minus a2 b1. It is called a determinant of second order. It refers to a square matrix which has the same elements a1, b1, a2, b2. So we study determinants of square matrices. In other words, every square matrix A corresponds to a unique number which is called its determinant and is denoted by mod of A or determinant of A. While matrix is an ordered arrangement of numbers and has no values, its determinant has a definite value. Now we find out the determinant of a square matrix. Number 1, let A be equal to matrix A, which has only one element. The determinant of A will be the determinant containing only one element A, that is equal to A. Second, let A be the matrix A1, B1 in the first row, A2, B2 in the second row. Its determinant A is equal to the determinant of A1, B1, A2, B2 within bars. Its value is A1, B2 minus A2, B1. Third, let's take a matrix A1, B1, C1 in the first row, A2, B2, C2 in the second row, A3, B3, C3 in the third row. Determinant of A will be equal to A1 times B2, C3 minus B3, C2 minus B1 times A2, C3 minus A3, C2 plus C1 times A2, B3 minus A3, B2. Expansion of determinant of A along the first row, that is A1 times the second order determinant with B2, C2, B3, C3 as its elements minus B1 times A2, C2, A3, C3 plus C1 times A2, B2, A3, B3 as its elements. Thus, a determinant of third order can be expressed in terms of the determinant of order 2. We now discuss the minor of an element of a determinant. Minor of an element of a determinant is the value of the determinant obtained on assuming the row and column of the determinant as removed. Thus, the minor of the element A1 in the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Here we remove the first row A1, B1, C1 and the first column A1, A2, A3. These are the row and column of the element A1. We are left by the determinant of order 2, that is B2, C2, B3, C3, which is equal to B2, C3 minus B3, C2. It becomes the minor of A1. Similarly, the minor of A2 in the same determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. We remove the row and column of A2, that is A2, B2, C2 and A1, A2, A3. We are left by the determinant B1, C1, B3, C3 of order 2. Minor of B3 in the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. We remove the row and column of B3. They are A3, B3, C3 and B1, B2, B3. We are left with A1, C1, A2, C2, which is equal to A1, C2 minus A2, C1 becomes the minor of B3. In fact, the determinant can be expressed in terms of the elements of a row or a column and the corresponding minors.